Sabers, Marsh here. So today we're going to take a look at general form of a circle and an ellipse. You want that Conic's foldable that we've been filling out. And today is basically completing the square round 2 today. So we're going to take a look at how do you complete the square and how do you make these equations look like they should. Now, ultimately, you're going to be using the final tab, the identifying conic sections foldable. So open that up for me. And here's some general information. This does not go in your foldable. So equation of any conic that we've made can be written in the following form. Ax squared plus bxy plus cy squared. This is called a general second degree equation. Now, this is all fine and dandy, but ultimately you can't graph that conic equation when it's in general form. So we want to actually get it into standard form for each of them. Well, circles, this circle could be ultimately multiplied out to look like that general form of an equation. I could also do the ellipse. I could multiply it out, do some getting rid of those denominators, all that fun jazz, and it would look like something like that. Now, ultimately, I can't graph this equation. I can only kind of graph this. So if someone gives me this, I need to know how to get it into the standard form. So how do you know which conic it is when it's been multiplied out? Because sometimes you just kind of want to be like, that's a circle. Okay, so ultimately you're going to pay close attention to who's squared and who's not. And you're going to look at the coefficients in front of the squared terms and their signs. Here's what you're going to look for. So if you have a circle, you're going to find that both x and y are squared. You're going to have both versions. And their coefficients and their other coefficients are going to be the same number and the same sign. So these are both a 1 and they're both positive. That's how you know you have a circle. If I want an ellipse, still x and y are both going to be squared. However, their coefficients are going to be the same sign, but different numbers. So like this has a 4, but they're both positive. This guy has a 1. That's how we know we have a circle versus an ellipse. So being able to identify them sometimes even helps us right off the bat, so then we kind of know what we should be getting out of it. So ultimately, if we wanted to graph these equations that's in general form, we need to be able to get it to standard form. That's when completing the square comes back into play. And you're probably like, Marsh, I don't remember completing the square. Ultimately, if you guys remember, it was with that whole plus blank thing. I know. Basically first quarter of this year. But here's the general steps to complete the square. First thing we're going to do is we're going to group the x guys with the x guys and the y guys with the y guys. So cats with the cats and dogs with the dogs. All right? We're going to send the constant numbers. We're going to kick them to the other side of the equal sign. So the right-hand side. We're going to make sure the coefficients, the numbers in front, of the x squared and y squared are going to be 1. If we're not, we're going to factor them out. Then we're going to take the number before the x, divide by 2, and square. So remember how we did that, right? It was to fill in the blank. We're going to do the same with the number before y as well. We're going to add these numbers to both sides of the equation, make sure to multiply, and then we're going to factor. And you're thinking, Marsh, that's a lot of work. It's okay. We got this, okay? So let's take a look at 29. So first thing I want to do, though, guys, is I want to look at this, and I want to guess what kind of conic this is. So using our little cheats, well, there's an x squared and a y squared, so it's either a circle or it's an ellipse. They're both the same sign, so that's good. But notice their coefficients are different. So in this case, this is in fact an ellipse. So I've identified him. Now I gotta get him into standard form. This is the hard part. So what you want to do is you want to group the x people with the x people, the y people with the y people, and kick those numbers to the other side. Well, there's no other x's, so I'm going to put 36x squared over here. And I'm going to put all the y's together stuff. Okay. And I'm going to kick the 27 to the other side. Now, since x squared does not have a y term or an x term, he's just going to kind of hang out there. I don't actually have to complete the square with him. So he's just going to leave as 36x squared. Now I got to do the y's, so I'm going to group them like this. Remember, we got to find blank. So I'm going to put a blank. Now, if I add blank over here, I better add a blank over here. And I got to make sure. Did I factor anything out? Nope. There's a 1 there. So I will do 1 times the blank. Okay, now let's say there's a 5 out here. Let's say I had a factor, then I would have been 5 times the blank. Be very careful with that. That's a very common issue if you miss it. Defined blank. So to find blank, it is b term divided by 2 and then square it. So I'm going to take 6, I'm going to divide that by 2, and I'm going to square. 9, right? That should be a 9 because 6 divided by 2 is 3. 3 squared is 9. So I'm going to get a 9 over there. And then, well, this over here is 27 plus 9, 36, it looks like. This is going to stay 36x squared. This now is a factorable equation or function or expression. So, well, it's going to be a y and a y. And two numbers multiplied, -3 and -3. So it's going to be y minus 3 quantity squared. Because you're completing the square. Okay. Now, all of these guys, when we were putting these things in, when we had them in standard form, they were always equal to 1, right? When they were ellipse. So we're going to divide everybody by 36. And I'm going to get x squared over 1 plus y minus 3 squared over 36. And that's going to be equal to 1. That will be my final answer for this problem. Whew, a lot of work, I know. Lots of math, a lot of algebra, but that's good because we haven't been really focusing on the algebra for a while. We've been graphing a lot. Let's take a look at 31. Notice we're jumping around. I know, scary, kind of weird, but it's because those aren't a circle or an ellipse. So we're going to take a look at 31. So first thing I'm going to look at is we do have an x squared and a y squared. They are the same sign, and they're the same coefficient. That means we have a circle. Okay, so we have a circle there. Now, I'm going to group the x guys with the x guys and the y guys with the y guys. So x squared plus 16x plus y squared minus 2y, and then we're going to kick that 38 to the other side. Now I got to make room for, there is 2 blanks, okay? So I'm going to group these guys. Put a blank there. I got y squared. Put a blank there. Now I got to have 2 blanks over here. Because I have 2 blanks on the left, better have 2 blanks on the right. Now let's find our blank. So I'm going to divide 16 by 2. And then I'm going to square it. So that's going to give me 64. 64. Notice there's a 1 out here, so I don't have to have that information there. Divide the 2 by 2. That'll be 1. Square that. I'll get a 1. 1 times 1, 1. Now let's factor. X squared plus 16x plus 64. That would be x plus 8 squared. Now if this doesn't happen, if you don't get the same thing twice, you factored wrong or you found the blank wrong. Okay, so be careful when you do that. Let's find this guy. What's a y minus 1? Yeah, minus 1 squared. And this is equal to, 64 minus 38. That's a interesting number. That looks like it would be the answer of 26. Now, since this is a circle, guys, it does not have to be equal to 1. So we're going to leave it in this form. Let's take a look at 32. So again, I'm looking at this problem and I am seeing both x squared and y squared. There is definitely a 9 and a 4 sitting out front there. So they are different signs. So that means I have, or different coefficients, excuse me. That means I have an ellipse. So now let's group the people together. Move the 193 over. Now, This guy, x squared and y squared, both have coefficients in the front. So I actually have to factor those numbers out because to complete the square, your a term, the number in front of x squared, has to be 1. So I'm going to factor out a 9 out of the x's. Put a blank there. I'm going to factor out a 4 out of the y's. Put a blank. And then I'm going to be equal to negative 193. Now, I can't just put plus blank because you see how it'd be 9 times the blank? So I'm going to make note of that. It's 9 blank plus 4 blank. Okay, so I remember to multiply. Let's find our blanks. So 10 divided by 2, that would be 5. Square that, that would be 25. So we'll fill 25 on both sides. 2 divided by 2 is 1. Square that. That will give me a 1. So, if I do my factoring here, this will be x minus 5 squared and y minus 1 squared. And that's equal to, ooh, jeepers. Well, 9 times 25 is 225. Add 4 to that, that's 229. Take away 193. I'm going to get 36 for an answer. Now, since we are at an ellipse, I'm going to divide everything by 36 because I can't have these numbers sitting out front there. 9 over 36, that would be, simplifies 1/4, I think. 4 out of 36 is 1/9. So y minus 1 squared over 9. And I'm equal to 1 now. There is a reason why I did those problems on the worksheets and on the videos. For the final problem, guys, I'm going to ask you to DIY this yourself, okay? So it is, in fact, a circle. So I'm going to ask you to try to complete this one on your own. And we will do this one in class together so that you guys can ask a question or two of me. Until then, though, that is the end of this video. I will see you later, Sabers.